Boston Dynamics just gave its Atlas robot a new pair of hands, and they might be the most advanced robotic hands ever built. At the same time, Figure AI unveiled its next-generation humanoid that can literally wash dishes, fold laundry, and charge itself. The race to build the first humanoid robot that's actually useful is reaching a tipping point, and the breakthrough is happening right now might decide which company defines the next era of automation. So let's talk about it. Alright, let's start with Boston Dynamics. Then they've just given Atlas a major upgrade. You've all seen Atlas before? The bipedal robot famous for its backflips and parkour routines. Well, this time the focus isn't on how it moves, but on how it handles things. The team's been working on giving it real human-like dexterity. And the result is a brand new second-generation gripper called GR2 that completely changes what Atlas can do with its hands. Backstory. When Atlas switched from hydraulics to full electric, it gave Boston Dynamics a chance to rethink what the hands could do, not just worry about legs and locomotion. That shift created an opening to focus more seriously on manipulation, grabbing, holding, twisting, releasing. Grippers are deceptively tricky. You need actuation, sensing all crammed into a small package. Because of that, Boston Dynamics took a long-haul view. The first version, GR1, had 3 fingers in a line, no thumb, and taught them a lot about mounting, ruggedness, and failure modes, like when the robot falls on the hand. Now GR2 is the step forward. This new GR2 gripper has 7 degrees of freedom. That is 7 actuators. 2 per finger for 3 fingers equals 6, plus 1 extra actuator for an articulated opposable thumb. That thumb is a big deal. Without a thumb, the robot's grasp options are much more limited. With a thumb, it can do 2-finger pinches, 3-finger grasps, and stabilize heavier objects by distributing force among fingers. But it's not just about moving parts. The gripper includes tactile sensing in the fingertips. Think of that as the robot's sense of touch. Under an elastomer surface, sensors detect deformation so the control system knows how much force is being applied. That allows the gripper to apply just enough force to hold something stably, without crushing or dropping it. And if something slips or falls, the sensors pick that up. The gripper also has cameras in the palm, a visual backup in tight places where the main vision system might be occluded. Mechanically, each gripper module is self-contained. All actuation is inside it so you can mount or remove it easily. It's designed with some ruggedness in mind because sometimes the robot might fall or land partially on the hand. The designers considered that and built in robustness to survive those events. Moving from GR1 to GR2, the biggest change is that thumb. GR1's 3 fingers were aligned, no thumb. GR2 adds the thumb, which dramatically increases what the hand can handle. They debated whether to add more fingers, but more fingers equals more complexity. Reliability problems, cost, development, speed issues. So for now, 3 fingers plus a thumb was judged to be the sweet spot for manipulation, dexterity, and practicality. And with that, they say Atlas can grasp almost anything thrown at it. Everyday irregular shapes, tools, variable objects, much more flexibly than before. That new dexterity is critical, because many tasks robots are heading toward involve not just strolling or walking, but actually interacting with items, bin picking, tool use, wiring, quality inspection, or small delicate object handling. The opposing thumb enables pinch grasps. The extra finger helps stability when rotating heavier or larger objects. The fingers can also bend backwards fully, allowing some clever grasping on the backside of objects. There are left and right versions of the gripper mirrored, so the thumb always comes around on the same side for each hand. Also, Atlas plans action strategically. If the left hand gives a more stable grasp in a given pose or avoids obstacles, it uses that. It does not adopt a fixed dominant hand like humans. The development path is about gradually raising the bar in dexterity. The designers foresee that over time a sweet spot in actuation, sensing, and physical design will emerge, and that the field will naturally drift toward more anthropomorphic designs as tasks demand it. Now couple that with what Boston Dynamics is demonstrating more publicly in new demos. This upgraded Atlas can pick up irregular shapes, adjust its grip in real time, thread a needle, assemble components, and manage objects with fine control. This is not just strength or brute force, it's nuanced manipulation. With that opposing thumb and tactile feedback, the hands can do much more subtle tasks. It's one thing to grip a block, It's another to reorient, twist, adjust, or delicately place. But there are still a few major hurdles ahead. And safety is right at the top of that list. In one viral incident, a similar robot arrival flailed during testing, reminding everyone how failure modes can be dramatic. Boston Dynamics has emphasized rigorous testing, balanced strategies, and fallback modes to mitigate that risk. You don't want a giant robot accidentally crushing bones or machinery because it lost stability. On the broader industry front, Boston Dynamics is racing against rivals like Tesla's Optimus and Unitree. For instance, Unit's G1 model is known for its anti-gravity recovery. If it falls, it rebounds. Those dynamic recovery capabilities could complement dexterous hands like GR2, and Tesla has shown off Optimus doing balancing or controlled motions, presumably heading toward fine manipulation. Another competitor pushing a different angle is Figure AI with its new Figure 03 Humanoid. They are aiming for general-purpose robots, not just industrial, but usable in homes, hotels, warehouses, etc. Their pitch is that they're going beyond lab demos into real deployment. Figure 03 has several improvements. First, it uses their in-house AI system Helix Vision Language Action to learn tasks by interacting directly. They claim nothing is T-operated. The new model is lighter, 9% mass reduction over Figure 02 and shrunken footprint. Its external design eliminates exposed metal parts, adds soft, washable covers, and uses padding to reduce risk in pinch areas. Because when these operate around humans, soft external materials help with safety. They also increased their sensor field of view. Each camera has about a 60% wider field of view. They also doubled frame rates, cut latency by 75%. Cameras are built into each palm to help when the main eyes are blocked, for example, reaching into a cabinet. Palm cameras give additional visual feedback to guide grasping. On tactile capability, Figure 03 uses custom touch sensors in the fingertips. Off-the-shelf sensors weren't robust enough. The sensors are claimed to detect minute pressure changes, sensitive enough for something like the weight of a paperclip. Fingertips are made of softer material for steadier grip. The robot stands about 168 men tall. That's roughly 5'6". Weighs around 60 kilograms or about 130 lb. Can carry up to 20 kilograms, which is 44 lbs, and moves at about 1.2 meters per second or around 212 meters per hour. Battery life is up to 5 hours per charge, and charging is wireless via floor plates up to 2 kilovolts. The robot docks itself. They've also geared their manufacturing towards scale rather than fully custom machined parts. Many components are made by die casting, injection molding, stamping to reduce cost and speed up production. They aim to produce 12,000 units per year to start with a 4-year target of 100,000 units through their BotQ facility in San Jose. That's ambitious. Scaling gives them leverage in cost, repair, supply chain. In terms of tasks, they show the robot doing dishes, interacting with human appliances, working at a reception desk, navigating stairs, handling changing layouts, even doing chores via voice commands. But the coverage from tech journalist David Zundy points out that while the demos look impressive, they still come from controlled company environments. So it's hard to know how the robot would actually perform in a real home full of obstacles, pets, and unexpected mess. Basically, there's no independent benchmark results yet. The real test is how these systems perform in messy, unpredictable real homes with kids, pets, obstacles, unmodeled surfaces. That reality gap is a classic issue. Robots in controlled labs look great. In the real world, things are full of surprises. From Boston Dynamics' side, integrating their hand capabilities, tactile sensing, thumb sensor vision, could help robots like Atlas tackle tasks that are currently human domain. The modular nature of the GR2 design means you could swap gripper modules or adapt to specific tools, and coupling that with powerful computation like NVIDIA's Jetson Thor chip, which is described by some as a platform for physical AI, might boost the AI that drives these systems. The robot needs to see, plan, react, adapt all in real time. That means high compute, efficient perception models, robust control loops. The competition is intense though. Tesla's Optimus has shown off balance and motion capabilities. Climbing robots with claws are pushing the envelope in physical repertoires. But Boston Dynamics grippers stand out because of human-like finesse, enabling tasks that demand subtlety, threading, wiring, manipulation of thin or delicate objects. Meanwhile, Figure AI is betting on combining generalized intelligence helix with improved hardware to bring humanoids into homes and small businesses. One tension is how far robots will replace human labor versus augment it. The promise is that they'll take over repetitive or dangerous tasks, freeing humans to supervise, manage exceptions, innovate. But job displacement concerns will inevitably emerge. That said, right now these robots are expensive and complex. They augment more than replace. Let me close out. Every few months it feels like robots level up again. And this time, they've gone from doing tricks to actually doing work. The line between demo and deployment is getting thin, and that's when things start to get interesting. So what's your take? Are we ready for this new wave, or are we moving a little too fast? Drop a comment, leave a like if you enjoyed it, and subscribe for more deep dives. Thanks for watching, and catch you in the next one.